Okay, Vestra. Today we're diving into something amazing. Oncolytic viruses. It's like futuristic sci-fi stuff, but real. Basically, they're using viruses to fight cancer. Can you believe that?
Yes, I can believe it. Given that it's happening right now. But please go on. I can't wait to hear your theory.
Oh, I'll get there. But first, I'm serious. These are viruses like actual viruses that scientists are modifying to target only cancer cells, so they leave healthy cells untouched. They're called oncolytic viruses. And they're kind of like little soldiers, sneaking in and sabotaging the cancer from the inside.
Little soldiers. Right, So, are we arming them with tiny microscopic swords and shields, or are we keeping it a bit more scientific?
Very funny. But actually, kind of. These viruses are armed with different modifications. Some are designed to destroy cancer cells directly, like they infect and break them down from the inside. And others can boost the immune system so it recognizes and attacks the cancer. It's like they're going in with different weapons. They even call some of them cold and hot weapons.
I see. So, the cold weapons are the ones that just get in there and tear the cancer cells apart, right? And the hot weapons would be the ones that make the immune system get all fired up.
Exactly. They're designed to trigger immune responses, sometimes by releasing what are called danger signals when they break open the cancer cells. It's like they're waving a flag that says, "Hey, immune system, look here." That gets the body's defenses focused on the cancer. Oh, and some of these viruses also change the tumor's environment. They can mess with the blood vessels that feed the tumor, or break down the matrix that protects it.
I'm getting the picture, armed viruses with a mission to infiltrate, destroy, and redecorate. Just how armed are we talking?
Oh, very. These scientists are going wild with customization. They'll tweak a virus so it targets specific receptors that are only on cancer cells, or they'll engineer it to replicate only in cells certain mutation, like a p53 mutation, which is common in tumors. That way, the virus practically ignores normal cells. It's all about precision.
Well, I can see how that would reduce the collateral damage. Don't want them spreading all over the place like, say, a pandemic virus.
Yes, no one wants that. They've actually found ways to keep these viruses super safe. For example, some viruses are programmed to recognize specific cellular markers that are unique to tumors. And they'll delete certain viral genes, so the virus can't thrive outside of the tumor's environment.
So, we're talking about a pretty sophisticated level of control here. They're not just letting viruses loose, but building in multiple fail-safes.
Exactly. And it gets even cooler. They're testing these viruses with other treatments like checkpoint inhibitors. When combined, these can turn tumors from what they call cold, where the immune system ignores them, to hot, where immune cells flood in and start attacking.
Turning a cold tumor hot. So, that's sort of like taking a silent intruder and setting off a full-on alarm system, getting all the body's security guards on high alert.
Yes. You're getting it. And these trials are showing it works. But of course, it's not a perfect science yet. Some tumors have barriers like an extracellular matrix that make it hard for the virus to get in.
So the cancer cells are basically putting up walls to keep the viral invaders out. That's almost strategic. The tumors are fighting back.
Right? But our little virus soldiers are evolving too. They can now break down parts of that matrix or even cut off the blood supply to the tumor. So, it's like tactical warfare on a microscopic scale.
Well, that is fascinating. And the idea of combining it with existing treatments to amplify the effect makes a lot of sense. If we can get the immune system working alongside these modified viruses, that's a serious multi-pronged attack.
Yes. And the future of all this. Imagine smart viruses that can adapt or even switch functions based on what they encounter in the tumor. Scientists are talking about using AI and big data to help design these viruses with even more precision.
AI-designed viruses, you say? Well, that's a nice touch of dystopia. But I see the appeal: fewer side effects, more personalized approaches.
Exactly. And one last thing, they're also considering the ethics. Some people hear virus therapy and immediately think, oh no, what if it spreads? But these OVs are built to be safe, stable, and really precise. There's a whole ethical framework to make sure these treatments are handled responsibly.
Good. I can imagine a few people might feel nervous about injecting viruses on purpose, even if they're engineered for safety.
True. But with all the testing and trials, plus the ethics protocols, it's looking really promising. I think we'll see more of these in cancer treatment soon.
Let's hope so. Cutting-edge science and a reasonable approach to risk, that's a combination I can get behind.
So, Vestra, would you call it an infection of hope?
I knew you'd say that. And maybe. Only because I'm in a strangely good mood today.
So there you have it, folks. Oncolytic viruses, the microscopic soldiers fighting cancer. Who knows what's next? Embrace the strange, everyone, and maybe the strange will save us.
Or at least give us something worth talking about. Until next time.